Now let's talk about oxidation and reduction. That is to say, like, we are going to talk about oxidizing and reducing agents. We are not exactly going to talk about balancing redox reactions, however, but we will explore the reagents. Permanganate iron is a great reducing agent, and in acidic medium it is purple in color. In acidic medium, permanganate iron can be reduced into manganese ions, which will form a light pink color or colorless solution. It decolorizes, and while doing so, it oxidizes another agent. This is the manganate ion, and it is also a good oxidizing agent. In acidic medium, it is green color, and and it can get reduced to form manganese ions, which are light pink and colorless. Light pink or colorless actually, and it does so while oxidizing the other compound. In basic medium, permanganate, it reduces to form manganese dioxide, which is black brown in color. The same could be said about manganese ions in basic medium, which is light pink in color, but in this case it acts as a reducing agent because it can oxidize to form manganese dioxide. If you want to reduce something, you can use manganese. If you want to reduce something in basic medium, you can use this, and it will form manganese dioxide, which is black brown in color. Chromate ion solution is also a great oxidizing agent. It is yellow in color in acidic medium and can be reduced to form chromium ions, which is green in color. It's also another kind of decolorization. The same could be said about dichromate ion solution in acidic medium, which is orange in color, and it can be reduced to chromium ions as well. This happens while oxidizing the other reagent. In basic medium and acidic medium, chromium ions is a great reducing agent. It can oxidize itself to form the chromate ion in basic medium and the dichromate ion in acidic medium while reducing the other agent. Here we can oxidize the oxalate ion into carbon dioxide using an oxidizing agent. If we oxidize the oxalate ion, it will form carbon dioxide. And we have discussed this earlier. We can oxidize and reduce the ferrous and ferric ions with each other, and iodine gas and the iodide ion with each other also, using the oxidizing and reducing agents appropriately. You can do it. Now these compounds are a bit tricky because they can behave as either an oxidizing agent or reducing agent. Well, it cannot exactly be taught the art of it can be learned. It becomes intuitive with time, but it's not exactly the most easiest to explain. But for now, just know that these compounds can be reduced and oxidized. They can act as both oxidizing and reducing agents, and in future episodes we will be able to see how they can be used so appropriately. The oxidation state of sulfur in sulfur dioxide is +4, and it can be reduced to form sulfur, which is in a zero oxidation state, or it can be oxidized to sulfate ion solution, which is in +6 oxidation state. Hydrogen peroxide has oxygen in its -1 oxidation state. It can be reduced to form water, in which the oxygen is in a -2 oxidation state, or it can be oxidized to form diatomic oxygen, which has a 0 oxidation state. -1 to 0 is a +1 increase in oxidation state. This is hydrogen sulfide. The hydrogen is in +1 oxidation state while the sulfur ion is in -2 oxidation state. It can in here it can undergo oxidation in which the sulfur goes from -2 to 0, forming sulfur, or it can, or the hydrogen can go from +1 to 0. It's a reduction reaction in which hydrogen sulfide reduces itself to hydrogen, and the sulfide ions shall be free. And these are the reducing and oxidation reductants and oxidants, and how they can be reduced and oxidized appropriately.